Hello and welcome to the channel. In today's video we're going to be looking at this card here. It's an Emulex Persyst Colour 2 and it's a bit of a mystery. If you Google that name you won't find very much information at all. As you can see, it's a half-length card for a PC, and from the name and general appearance you might imagine that it's just a 16 colour Cga graphics card. But the chips are from about 1985, and this would actually be a little early for a clone Cga chipset. So it has to be something earlier still. But check out the large square VLSI chip in the upper left here. That's almost certainly holding some interesting secrets for something this early, and that's what we hope to get to the bottom of in today's video. Also in this video, we try to get to the bottom of what's going on with my hard drive in my XT clone machine. Let's start with the Persyst Colour 2 card. It's probably a late 4-color Cga graphics card. It has the Motorola 6845 CRT controller chip, which you'd expect to find on Cga, and it doesn't have any of the crystal frequency oscillators that you'd expect to find on a later Cga card. This card probably runs at a frequency set by the main board in the computer, and that almost certainly means that it's Cga. For comparison, here's an original IBM EGA card. It has a 16.257 MHz crystal oscillator on it, and that's what you expect to find on an EGA card. Well, let's just plop the Colour Persyst card into my PCXT clone, connect it up to a Cga monitor, switch the machine on, and see if anything happens. And yeah, it seems to be, so at least we know that the card is actually working. About the only Persyst Colour 2 information I can find online is this old set of files from a BBS. And you can see here, Persyst Colour 2 diagnostic. We'll have to try that out. There's a few other Emulex products here as well. There's the Persyst Colour Combo and Mono Combo. And I found lots of references to these online. They seem to have been pretty popular cards. There's also the Persyst BOB, and I think this stands for Best of Both. And I actually found some advertisements for this online. They seem to have actually been advertising at that point. And there's something here called the Persyst Stretch, which presumably was a memory board, and I think it might be this one here, which I found online as well. I don't know what the other stuff is in here, but we're definitely going to give this Persyst Colour 2 diagnostic a try. Well, there were just 4 files in the zip file, and there's just one that I can actually run. So let's try it out and see what happens. There's just one available diagnostic colour, so we'll run that. And obviously we want to do the colour video test. The first thing it does is bring up the configuration of the card, and you can't actually change any of these. If I select any of them, it just says it's defined by hardware. This is the main part of the diagnostic program. There are board level tests, text mode tests, and graphics mode tests. And also you can test the printer port on the card if you have one. Let's run the board level tests and see what happens. And we'll just run all board level tests, which is option 8. And we'll just do one pass. And nothing particularly bad happened there. So we'll run the alpha mode tests, and again we'll just run all of them instead of running them one at a time, and one pass. So this is the character set. It looks pretty standard in both the high and low resolution, and all the colours look okay, and it says there are no errors, so that's good. The other one of interest is the graphics mode test, so let's run that, and again we'll just run all of them. One pass. Shows the medium resolution mode and the high resolution mode. Really nothing very extraordinary here. And there's also a linearity test to make sure your display is not wobbly looking. But that's about it, and it says all the tests pass, so the card is in working order, which is good news. In order to check for anything extraordinary, we're going to have to look a little bit deeper, so I'm going to run Jim Leonard's Cga Compatibility Tester. The raster bars seem to be working okay, no problems. You won't see it at 30p, but this is how the half-working interlace mode usually looks on Cga. And the scrolling seems to be okay. And also the horizontal scrolling's okay. Actually, I ran every single test, and this thing seems to be 100% compatible with an IBM Cga card. But check this out. The read speed for the memory on this Cga card is really fast. It's almost twice as fast as an original IBM Cga card. And that's just not what I would expect. Back in the day, you weren't trying to pick the more expensive memory part to compete with the IBM Cga card in performance. You were trying to make a cheaper clone that could compete on price in the marketplace. I wonder actually just how accurately they've emulated the IBM Cga card. I have a little program here which uses an improper mode, which is just a quirk of the IBM Cga. It just moves a little black cursor around, and on an IBM Cga card you'd expect to see it duplicated and sometimes disappear, but it doesn't seem to happen here. So they support this improper mode, which is really interesting, and deal with some of the bugs that were in the IBM Cga card. Well, if that works, then I'll try this improper mode test. It's very high resolution and it just alternates pixel colors, but the pixels are so small you can't see them individually, so it looks like a whole bunch of different colors. Well, that seems to be okay, so let's try the demo that I wrote for that improper mode. Yeah, that's a bit weird. That's not working at all. It's totally messed up. I wonder why that is. Very strange, but I'll try running just an ordinary Cga mode demo. And this one should work, no worries. Of course, it should run really fast, given how fast this card is. What on earth is going on there? That makes no sense whatsoever. This is just an ordinary Cga mode. Surely that should work. Well, I did say that I was looking for something interesting with this video card, but this puzzle has me beat. Why would it be 100% compatible in Jim Leonard's Cga Compatibility Tester? It passes the tests that I threw at it, and then the demos don't work. That's just really odd. Some of you might have noticed earlier when I showed the listings on Google for this particular card that it was advertised online as an EGA card, but I don't think this can be correct. So let's rule that out first. Let's take a look at the memory chips here and see what we have. And yeah, according to the datasheet here, there's just 16K words of 4 bits each, which means that each of those chips is only 8 kilobytes. And 16 kilobytes is exactly what you'd expect for a Cga card, definitely not an EGA card. Well, there's quite a few jumper settings on this board. There's a whole bunch in the upper left of the board, and there's also a couple in the lower left as well. So maybe there's just some setting that needs to be changed to make things more compatible. But in that repository that I found earlier, there's a list of settings for the Persyst Colour 2, and it turns out that most of them are for the parallel port, which I don't actually have on my card. There's just a big gap where that would normally be. And so the only relevant setting is the one for the Cga port, which is just to change over to a 4K by 8 character ROM. And that's not going to fix the problems that we're having here. In order to try and narrow the problem down a little bit, I wrote a program to just put a pattern into Cga memory, and it seems to be correct. I've compared this with another machine. So it's not just putting data into the Cga card that's the issue. Maybe it's the background color that I was using in my demo. So I changed the background color here and redrew the pattern, and it still looks exactly right. So that's not the issue. And maybe it only happens if you write data into Cga memory really often or really fast. So I just had it redraw the same pattern over and over again 100 times. And well, that just looks completely steady to me. So I don't think that's the issue either. Well, I managed to find the problem, and it's a really interesting one. It has nothing to do with the graphics card at all. In fact, here is the demo running on my IBM PC with the Persyst Colour 2 card. And as you can see, it's working perfectly well here. The issue is to do with my PC XT clone machine. You see, in a recent video on the channel, I put an NEC V20 CPU in this machine. It's supposed to be a drop-in replacement for the original 8088 CPU that was in here. And obviously, I've managed to find, without actually trying, an incompatibility between these CPUs. And here's the proof. It's my icosahedron demo running on the XT clone machine, just with an 8088 CPU instead of a V20. And it's really smooth. It's running at 10 megahertz here, but of course the card is also really fast. And now I should be able to run my Improper Mode demo, and apart from a little bit of snow here, which you'd get on the IBM card anyway, it seems to be working just perfectly. And this underscores just how compatible this card is with the original IBM Cga card. It's an extraordinary level of compatibility, which I've rarely encountered in any card. So I wondered if this card held any other secrets other than great performance and compatibility. So I wrote a program which every time I hit a key is going to randomly send data to ports that aren't normal Cga ones. And no, nothing found. So this card just seems to be a really straightforward Cga implementation, but really compatible and really quick. Well, let me know what you think in the comments below, but I find this card rather intriguing. First of all, there's the fancy name, the Persyst Colour 2, which kind of implies that it had a predecessor, but I don't find any additional features. I guess it kind of makes sense that it has that fancy chipset. This could have just been a cost-cutting measure. Pack more components into a large IC, halve the length of the board, and save manufacturing costs. But if you're just trying to make a cheaper clone, why make it so fast? That just doesn't add up. So I feel like we're overlooking something here. I'd kind of expected that fancy chipset to represent partial progress towards EGA support, for example. And this is where I really wish that we had some schematics or maybe even just some marketing material back in the day that we could get some hint as to what to look for. If you have any additional information about the Persyst Colour 2, please let us know in the comments below. I'm really intrigued about this one. But let's move on today to my XT clone machine, which unfortunately is having a problem with its Seagate hard drive. These have a reputation for being super reliable, and so it's really surprising that mine appears to have died. So let's take a look and see if we can figure out what's going on. For those who follow the channel, you might remember that my IBM PC had a problem with sound. And it turns out that it just sprang to life again today. So I think it was just a loose chip or maybe a broken wire in the speaker cable. But on this XT clone machine, the hard drive is really having some weird issues. Take a listen to what it does on boot up. Well, I don't know what's going on here, but I've actually been having problems with this drive now for about a month. And all of a sudden today, it's just working fine. So while I've got the chance, I'm just copying everything off to back it up on a zip drive. Well, I can't believe my luck. I just got through copying all the files off the drive that I'd personally written, and I thought, well, I may as well just back up some of the other stuff as well. I mean, I can get it all on the internet, but it's just convenient to have it on my zip drive. And lo and behold, the drive fails again. And this is the symptom that I'm seeing, data error drive C. And basically, this will even prevent it from booting. In fact, let's try that now and see what actually happens. I'll just do a Control-Alt-Delete, and we'll see if the drive actually makes it through to boot. So it did detect. Let me just see. So actually the drive seems to be working at the moment. It's just going through its normal startup procedure. It seems to go up through all the cylinders and back down again through all the cylinders. And at the moment it does seem to be booting, which is really bizarre. So I don't know why it's sort of intermittent. This is how it was until about a month ago, and then about a month ago it just wouldn't boot at all. Nothing was working, and it's been like that ever since. Hold on a moment, let me back up a bit here. Sometimes the mouth flaps when doing a live shot and the wrong thing entirely comes out. Let me tell you what really happened with this drive. So I've actually been having problems with this for many months now, and initially it was just the occasional read error that would go away if you persisted. And I assumed it was because I'd set an unrealistic interleave factor. But viewers have assured me that this wouldn't normally cause a problem with accessing the drive. Then, after a while, the drive stopped booting, so I could still access it from a floppy disk. I just couldn't boot the drive itself. And then, not so long ago, although it's probably more like 2 months rather than one, the drive stopped accessing or booting and started making a horrible noise whenever you tried. And this includes whenever you tried to boot from a floppy disk, because DOS tries to access the hard drive as part of its boot up procedure. So I was just used to waiting for the drive to finish this horrible grinding noise every time I booted from floppy disk, and I have used this machine a lot in the past few months. So you can imagine my surprise when the very first take that I did yesterday to show you this problem, the drive not only accessed, which it hasn't done for months, but booted, which it hasn't done for even longer. So this was really a surprise. I managed to copy all the files off the drive that I'd personally written, which was great, and then almost on cue, the drive stopped accessing immediately after I'd done that. So I talk about coincidences, but I guess I'm just used to these technological coincidences every time I point a camera at a computer. But what could go wrong with this Seagate ST-225 drive? These are notoriously reliable, so I hadn't expected any issues at all. Well, one of the most popular videos on the channel is comparing the performance of MFM drives like this one and an IDE drive and a hard card. But viewers noticed that I didn't set the interleave factor optimally for this drive. The interleave is basically how far it is between consecutive numbered sectors. If you set the interleave too tight, then it can actually miss sectors and you have to wait an additional revolution before the sector comes back around under the head. If you set the interleave too loose, then there's just wasted time while you wait for that sector to roll around under the head. So setting that factor optimally for the speed of the machine can radically increase performance. Now, I'd actually done this off camera after viewers made that comment, and not long after that I started to notice issues with the drive access. But since then, viewers have reassured me that this can't possibly be due to the interleave. Well, the other thing I noticed is that the problem was more severe as the drive heated up. The drive can change shape slightly as it heats up, and maybe things are just no longer under the head. Perhaps I formatted the drive when it was stone cold and should have waited until it had warmed up before I did that. So that's actually what I'm going to start with today. I'm going to low-level format this thing after letting it heat up for 45 minutes, and then we'll see if we can get reliable access. But first of all, let me just start this machine up again today and see whether it's still booting. I very much doubt it, but it's worth a try. It's cooled down overnight, of course, and so it could be stuck again. And I don't believe it. Finally, I get it on camera. That's the noise that I'd heard previously. You hear that back and forth from the heads. But we need a cheap and reliable way to tell whether or not the drive is still faulty. Otherwise, how will I tell whether it's been fixed? And so I'm using an old program here called SpeedStore, which has a diagnostic mode. And as you can see, very, very quickly, before it's even finished a single pass, the surface analysis has shown up a whole load of head cylinder combinations which it considers to be faulty, and I'm hearing that weird noise coming from the drive pretty regularly. So this is definitely going to tell us if the drive is still faulty. So I'll let this run through for a few passes and really warm the drive up and see what the result is, and then we'll do a low-level format, which this program is also capable of, and see whether or not anything changes. Well, interestingly enough, it only seems to be having issues on the beginning portion of the drive. You can see that all of those cylinders that have problems here are below about 80 or 90, and yet it's now up to cylinder 475 on the drive and hasn't found any other problems. So this is kind of interesting. It means that maybe there is an actual issue with the surface of the drive itself. Well, we'll find out, I guess. Well, I didn't actually notice that while I was filming, literally explaining that there hadn't been any issues with the drive from about cylinder 90 onwards, all the way up to 470 something, that there was actually an issue showing up at 476. I guess I'm just used to these kind of coincidences as soon as I point cameras at things these days. What I'm doing now is running the program again from scratch just to make sure that there are still problems at the beginning of the drive. The drive is a lot warmer now. I ran a bunch of seek tests, which all passed incidentally, and I ran this media surface analysis for ages. So now there are fewer issues. They're still there, they're just not as many. So what I want to do is do a low-level format, which this program calls initialize, and see how that changes things. And then of course I'll monitor the drive over a few weeks and report back to the channel whether anything's changed. Well, I've set it going doing its initialization, which should probably be called low-level format, and it's not much to look at, it's just counting up through the cylinders. I did set the interleave to the default, which is 5 in this case, and we'll come back to that in a later video if we get the drive working okay to check out how that changes performance. Well, that's quite interesting. After the low-level format, this is the list of head cylinder combinations in the defect table. And if you go back in the video and check, you'll see that this is identical to the list that we had when the drive was warm. And by the way, on the drive is a label which gives the defects that were known at manufacture time, and there were none. So these are new defects that have accumulated over the course of the drive's life. So what I'm going to do now is mark these as bad, and then I'm going to do a partition and a format of the drive, and then use it for a while and see how it works. Probably there are some issues that show up only when the drive is cold, and we'll come back to that in a later video and check out the results. Well, interestingly enough, if you use this program to lock off the bad sectors, then it actually won't allow you to partition the drive because it says the partition table is corrupt. So this might actually explain what's been going on this drive. Perhaps there's actually damage to the drive in one of the really critical parts. At any rate, I've reinitialized the drive and now it's allowing me to put a partition on. So that's all I can really do for now, and we'll just see what happens. Well, unfortunately no dice. I did manage to put a partition on okay, and it even went through and checked for defects. But unfortunately when I go to format the drive, it just says that there's a general failure reading drive C. And this is most likely because some really critical portions of the drive, like the partition table, have been damaged. And I'm not sure that there's an easy way to move those. So I think we're basically stuck at this point. This drive may actually not be usable. Well, sorry to leave you on a little bit of a cliffhanger there, but I've actually run out of time for this week. But there are a few other things that I haven't looked into, and I'm sure that you guys have some suggestions as well. If so, put them in the comments below. The first thing I could do is to use SpeedStore to do the formatting, which it seems to be able to do, instead of the DOS format command. And there's also something called a SpeedStore partition as opposed to a DOS partition, which is probably worth looking into. And I also have a vague recollection of some version of DOS allowing you to put the partition wherever you want. So you can skip over all of those bad sectors at the beginning of the drive. For some reason, the version of F-disks that I have at the moment doesn't allow me to do that, but that's something that I can look into. I'm really not sure if it's possible in this particular case. At any rate, there's clearly more to be done, and I'll come back to this in a later video. And if you'd like to see that, don't forget to subscribe. But for now, unfortunately, that's it for this week, and we'll see you in a later video. Bye!